So for number 21, I'm going to go ahead and start by writing my givens, like I always do. I'm going to say that angles QRS and PSR are supplementary. And this was just given to me. So my step 2, I'm going to say that, kind of ignoring my given statement, I'm going to look at what I have. So I'm trying to prove that QRL is congruent to PSR. So I'm trying to say QRL right here is congruent to PSR here. That's what I'm trying to say. Well, I know that QRS and PSR are supplementary, but it doesn't really help me right now. So I'm going to go ahead and start by saying that QRL and QRS, so this angle pair right here, I'm going to say that that is a linear pair. So QRL and QRS is a linear pair. QRL and QRS are a linear pair. And I know that just because of the definition of a linear pair. Okay. So if I know that two angles form a linear pair, I know right off the bat that they're supplementary. So I'm going to use that knowledge and form my step 3 and say that if QRL and QRS are a linear pair, then they're supplementary. So QRL and QRS are supplementary. And that comes from the linear pair postulate. All right. And I'm going to go ahead and draw a line between these two. Created an if-then statement when I did that. And so my step 4, I'm going to say that finally I can say that QRL is congruent to PSR. And I know that because I have two angles that are supplementary, QRL and QRS. Let's think about that. Those two angles form a linear pair in green in the diagram. So if those two angles are supplementary, and I know that QRS and PSR are also supplementary, that was my given. QRS and PSR are supplementary. Well, if I know that, I can say that since I have that common angle there, QRS, I can say that QRL and PSR are the same angle. So I can finally say for my step 4 that QRL is congruent to PSR. And that comes from my congruent segments theorem. I'm sorry, congruent supplements theorem. I had that common angle between my 1 and my 3, QRS, and if I knew that it was supplementary to two different angles, that those angles were the same. So this came from here and here. And I'm done.